Okay, we're ready to perform our first light. So you can already see that I've started the SpectracyberRPi main program. I've clicked on the commander. It's now grayed out because we can only run one commander at a time. Commander window is up and running, and we're ready to get started. Now, before we get going, let me explain. I've set for a bandwidth from -200 to +200 between the red and blue Doppler shift regions. I've chosen a mode of spectral and a meridian scan. Since my antenna is not movable, I have it located fixed on the meridian and tipped at whatever declination angle I want to detect. Timers are currently running. Everything is fine. It's got a scan timer here set for a period of 30 minutes. I don't want to take data for 30 minutes, so we're going to turn the scan timer off. So we set it to off. So what's going to happen is only going to scan from -200 to +200, and it's going to stop. And the data would be ready for us to be saved. It'll be put into a temporary file, temp.csv. If I like the data and I want to keep it, I click on the file, save as, and I can put it in any subdirectory I want. Now, before we get started, we have to take a look at our gain. Right now, I've got the gain, the DC gain set for 1 dB. I'm going to increase this to show you. You may want to start off at 1 dB just to be sure that your system's working for the first time. We've got a resolution rate of taking data about once a second, and this is an approximate number, but it's reasonably good. And now we're ready to get started. But before we go, I've got my gain, dB gain set to 12, because I know for me that's what's going to work on a SpectraCyber 2. You might have to choose something different on a SpectraCyber 1. And be sure to set your offset voltages accordingly so that you don't go off the scale. Now, we need to test. Are we going to be going off the scale? Are we going to be within range? So click on antenna, click on align antenna, and what should happen is, in a few seconds here, it'll pop up on the screen. There'll be a figure here that'll show us a vertical bar, and you can see what the gain is. So the gain for me is about 3 volts. On a SpectraCyber 2, the maximum range is from 0 to 5. On a SpectraCyber 1, it's up to 10 volts. So you should put yourself someplace reasonable where you know you're not going to go off the scale. I picked someplace in the middle. All right, so I know I'm going to be fine at this point. I'm going to close it by clicking on the X button, and we're ready to get started. So the first thing to do is to do something that gives you good feedback. We're going to just use the scanner and use a live scan. Now, nice thing about the live scanner here is that you will actually see the curve being displayed live. If we wanted to run in the background, however, we would have clicked on the scan button here, which has now gone red, and that would run in the background, but you will not see a curve. That's used for project modes, and it has its uses that you'll find later on to be very good. Now, you notice something here. Because I have this dB gain, this DC gain set to 10, the axis here has been zoomed automatically. This is a nice feature that is built into the scanner. The scanner will automatically zoom and try to keep the signal within the range of your SpectraCyber. Of course, it can go off range if you've put in too much dB gain, but if you've done it properly, it won't go off. Everything's fine. Now you can see that there is a signal rise here. We're actually getting a signal. Now, I don't know what we're looking at this point. There's probably not very much gas in this region, because I can tell you that the antenna is not pointed into the galactic plane. But we can see that there has been a rise here. So you can use this feature to get a little bit more detail on your signal. Just be advised that on the SpectraCyber 1, it's a real gain, and you can drive yourself right off the top of the maximum range of 10 volts. Just be sure you have properly set your offset voltage, and you can actually see the signal with a little bit more decibel DC gain here. Anyhow, that's the nice feature about it. This will run. I'll let it run till it's completed, and you'll see that it automatically will stop. We'll take a quick look at the plot of the data, and we'll have our first run. So it's almost complete. What we're going to do later is we're going to click on this plot command up here. We're going to bring up a standard plot and show you what it looks like in an unzoom mode. This is the signal, the ordinary signal plot that you can have, and it asks you if you want to see it at maximum scale. I'm going to say yes. If you say no, you'll actually see this thing again, very similar to that. It'll be zoomed in with a little bit more of a curve. That's going to disappear, of course. We're done. Now you can see that was the signal. We didn't have a whole lot of change here, but then of course we're not in a good area where there's a lot of gas. Now the file can be saved. Let's go ahead and save as. We're going to save it. It's going to default to the temp file. Of course, you could save any other file that you wish, but I'm going to save the temp file, and we're going to save it. I'm going to call it, I'm going to rename it to say my temp file. Okay, and now we're going to save it under a new name, and it's going to tell us it's going to copy it from here to there, and it's going to copy that file, the temp file, and rename it to this, and it's going to have it in the SpectraCyber directory on my hard drive, which is attached through a USB port. I have a 4 terabyte hard drive connected to my Raspberry Pi. We'll talk about that later. In any event, it's been saved. Now, if I'd like to take a look at it, I can come back over here and open up this file. And let's see, I'm going to go to plot. I'm going to go to plot, and let's plot it in right ascension. Just like we did down here, we should get something similar, and I want to pick well, it should have been saved. I don't know why it's not. There it is. Okay, yeah. All right, we open my temp file, and we're going to plot it this time at not in maximum scale, so we can see it zoomed. You notice it looked very similar to what we had on the other one, and now we're in a right ascension. So that's basically it. For one last thing, take a quick look. Let's open it in LibreCalc. Take a look at what the data looks like. It's defaulted to the temp file, which is still stored here. It's also stored here under my temp, but we can go ahead and just open it up this way. It's the same thing. This has already been set to take commas, semicolons, and tabs. Click on the OK button, and here is the raw data. This is the raw data. If we export this data, there'll be a lot more information. Note the unique feature here. There are 2 header files in this file. It shows us some information up here as to where the antenna is pointed, and then it gives us the frequency, the universal time, the voltage, the Julian day, and the sidereal time. And so that's it. That's basically FirstLight. We'll have more to learn later on some other lessons, but I hope you enjoyed this lesson.